All right, what I want to take a look at today is how exactly you can go about better understanding service discovery with DNS inside of Kubernetes. And to do that, I'm going to start a new Kubernetes cluster here with Minikube. So this is a brand new environment. We're going to take a look at how DNS is set up. We're going to take a look at the DNS records out of the box. All right, once that's done setting up, I can get everything here in the default namespace, and there is the Kubernetes service. And so if I wanted to take a look at DNS resolution of services, for example, the Kubernetes service, well, I could run a container inside of a pod inside of the cluster. And I've got one here. It's using a little image that I have some tools built inside of it, like DNS lookups, for example, NS lookup. So I can run that. That'll open up a pod inside of the cluster, inside of the default namespace right now. And so now I could go about using the NS lookup command. And then I could pass something like Kubernetes. And I get back an IP address. I could also do kubernetes.default. That also resolves. If, however, I do something like foo, that's not going to resolve because there's no foo service in the default namespace. Or if I did something like kubernetes dot and then kube-system, that's a different namespace that exists but doesn't have the service, so you can see it doesn't resolve. So when it comes to resolving services, you have to know a bit about the structure for building up a name to request or a name to resolve. Now, as an alternative to making requests here at the command line, which is kind of like shooting in the dark unless you know what you're doing, I could use something called a DNS zone transfer. For example, I could use the dig command here with axfr. That's a zone transfer request against the cluster.local zone. When I run that, though, I'll get a transfer failed, and that's because it's not set up to be permitted. So out of the box, the DNS server that's set up inside of my Kubernetes cluster doesn't support a zone transfer. However, if I zoom out a little bit here and give myself some more space, down below here, if I get everything inside of the namespace kube system, if I take a look inside of here, there's a couple of interesting things. We have a deployment for coredns. So in my case, the Kubernetes DNS provider is coredns. That's the case with Minikube. So if you don't have coredns, you're not going to be able to follow the same steps, though it's possible you'll be able to configure alternative providers to do the same thing. So that's the deployment, which means that up here you can see here is the pod for that deployment. And then a little further down, you can see here's the service. And if I clear this out, and instead of all, I do CM for config maps. Right at the top of the list is coredns. This is the configuration for that coredns instance. And if I grab that here, I can then dump out the contents as YAML. And you can see right here is a core file. This is how you configure coredns. And then inside of here, we have a series of directives like ready for the ready plugin, Kubernetes for the Kubernetes plugin. So this is what sets up coredns to use the Kubernetes API to resolve record requests, for example, for cluster.local. And then there are other plugins like Prometheus for metrics. So what we could do is we could modify this file, which would then reconfigure coredns. And we could add in the ability to do a zone transfer. So if I pull back my git here, change this to edit, then get rid of the YAML on the end. So I'm editing the config map for coredns. I can come down here and then among the list of plugins or directives, I can add transfer, add some braces. And then inside of here, I need to specify who is allowed to request a transfer. And in my case, I'm just going to do a 2 and an asterisk to allow anybody to request this, anybody that can hit the DNS endpoint. All right, so I'll go ahead and I'll save that. Well, actually, before I save that up above, I want to run one more time for you the transfer request. You can see that fails. All right, so I'll go ahead and save the configuration change. In fact, I can just exit out of that. And then up above, if I give this enough time, the configuration change will flow through coredns. And eventually, I'll be able to get the zone transfer records. Run this again here. Still nothing. I could, if I want, watch this. Every half of a second, I could try to resolve again. And just sit here and wait until this comes through. Make a little more space here. So the watch command is just rerunning that dig command every half of a second. And there you go. I've now got a zone transfer dump here with all of the DNS records that are available for resources inside of Kubernetes. And again, this is a default install with Minikube, so there's not a lot going on here. And if I quit out of the watch and instead run the command here, I've got some coloring that can help out. You can see among the records here, we've got kubernetes.default, which of course maps to the IP of that service. Down below, I could get all again here. Here you can see the IP of the Kubernetes service that matches what we get for a DNS record up above. And then further up here, we've got kubedns and the cubed system namespace. If I want down below, I could grab that again. And the service here has 0.10 as the IP, and you can see up on the record here, the corresponding 0.10. So basically 2 services are resolving right now, as well as some SRV records, for example, for the various ports, 53, both TCP and UDP for DNS, and then 9153 for the Prometheus metrics. Over on the Kubernetes side, you can see we've got port 443 for the API. So that's how you can set up a zone transfer to dump out all the records that you have for your services. And for the grand finale here, I've got some manifests in this directory, and the only one I care about right now is the normal.service. If I dump that out, the important part is that I have a port here of 8080 for the service. Keep that in mind, because if I go ahead and apply that service, maybe I'll up above here, I'll also run the watch so you can see the changes, and I'll add -d flag to watch so it flashes the part that changes. All right, we'll do that. And then down below, when I apply to create that service, there you go. You can see we get 2 new records. We've got our SRV record on port 8080, which is the port we specified in the normal service manifest. And then if I get all these services in the default namespace, you can see here's the IP for that normal service, and that matches the IP up here in the DNS record. So put this in your toolbox. It's a great tool to have. And watch out for an upcoming video where I use this to help understand better what goes on with a headless service versus what we saw here with a normal service.